Scientific writing, like other forms of communication, is a two-way process. Just as any kind of communication is useless unless it is received, a scientific paper is useless unless it is received and understood by its intended audience. In order for any paper to be understood, it must be written clearly. Although clarity is important in all forms of communication, it is especially important when something is being said for the first time. And most scientific papers are first-time papers.
Today I'd like to discuss with you how to complete a special type of scientific paper, the lab report. Lab reports are based on experiments having specific objectives, which often require the use of special equipment. Laboratory exercises may be done as a member of a team or individually. The number of people involved may vary depending upon the type of exercise and the equipment needed to perform the experiment. During the laboratory exercise itself, your primary goal will be to collect accurate data. I stress accurate because inaccurate information can really lead us to erroneous conclusions, something I really want you to avoid. Always strive for accuracy within the limits of the equipment we're using. The lab report itself is going to consist of 7 parts, 6 if we don't have any graphs. The order of the presentation is as follows. We're going to do a cover page, we're going to have a theory discussion, summary of procedures, a data sheet, sample calculations, graphs, and conclusions. The cover sheet is required and will normally consist of the title of the experiment, the date it's performed, and the names of your partners, if you have any, all properly spelled. All the information needed to complete the summary of procedures, the data sheet, and the section on sample calculations, this, and this, will normally be obtained in the laboratory. As I said before, you may or may not be provided with handouts to assist you in completing your report. I think that you will learn a great deal more about the subject if you're required to complete all the following 4 steps on your own. These are collection, analysis, organization, and presentation. If you do that, rather than just collecting the data and filling out a data table which has been provided, you'll be much better off. Therefore, you should plan to develop your own data sheet. The data sheet should include all of your data and any results which you calculated using the data. All the data columns should be labeled with an appropriate descriptive name for the data item, an accepted abbreviation for the name, and the units in which the data is presented. For example, I have a little table up here on the board. Let's say, for the sake of argument, that we were going to calculate the volume of this rectangular solid. It has a length, a width, a height, and we're going to calculate a volume. We've got the abbreviated name L, W, and H in here, and V for volume. The units that we're going to calculate each one, or get the data for each one of these, are centimeters, 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 and our volume is going to be calculated in centimeters cubed. So we've prepared our data table to put in the data. Now, again, assuming for the sake of argument that I have the right numbers for this rectangular cube, or rectangular solid, let's say we had a length of 4 centimeters, a width of 2.5 centimeters, and a height of 1 centimeter. The volume for that, when we calculate it out, would be 10 centimeters cubed. The sample calculation that we're going to do to show how we arrived at that volume will consist of the volume equals length times width times height. And we would then write down that the volume of this rectangular solid equals 4.0 centimeters times 2.5 centimeters times 1.0 centimeters equals 10.0 centimeters cubed. The sample calculations itself should include an example of each type of calculation you're required to make in the process of analyzing and reducing your data, such as this. The remainder of the lab report is the formal description of the physical laws you were trying to verify, how these laws were established, and how your data was used to verify these laws. This is called the theory discussion. The information you were trying to find and how you accumulated your data to support your objectives is called the summary of procedures. And finally, your conclusions. Were you able to meet the objectives of the laboratory exercise? Did you or did you not verify the laws that you were investigating? How accurate were your results? And was the accuracy of your lab within acceptable limitations? Considering the equipment and the accuracy of the measuring devices we were using, we always have to take that into account. These last three areas are by far the most important. Most experiments, if done properly, will yield reasonably accurate results. However, what I'm interested in determining is whether or not you understand what you were doing, why you were doing it, and what you found out. I want you to write the lab report as if you were trying to sell this report to your boss. In other words, it needs to be thorough, accurate, and concise. You're trying to prove that you know what you're talking about by describing clearly what you found out, your conclusions. That's the part the boss is most likely going to be interested in. If he or she finds your results interesting, your report may be studied more carefully to make sure that your approach was sound and that you adequately tested your basic hypothesis. Let's look at each of these three areas separately. The first of these is the theory discussion. In this section, I expect you to describe the basic hypothesis that is being tested. It will usually be given in the objective of the lab. In testing the hypothesis, you will be trying to verify some physical law or laws which may or may not have been described quantitatively by a mathematical model, an equation. I'd like for you to attempt to verify whether or not the model is an accurate representation of what really occurs in your experiment. It may be necessary for you to develop some exercise-specific equations to help you analyze your data. It's important that you explain the derivation of any such specific equations. This is really the most important part of the exercise for you. If you can explain the theory behind the exercise clearly, it's going to reinforce your understanding considerably. I often hear comments like, "I understand it, but I can't explain it." When I hear that, I'm reasonably certain that the person making the claim doesn't have really a clear understanding of the material. When you take the time to organize your thoughts and then write a clear description of what you did, why you did it, and what you found out, there's a much better chance that you will understand the material. The next item we want to discuss is called the summary of procedures, right here. In this section, you're going to state the objective of the exercise. You're going to describe the equipment or specimens that were used and how you used them or studied them to obtain the data to complete the exercise. Additionally, you're going to describe how the data was used in the calculations to obtain the desired results. And the last one probably is almost as equally important as the theory discussion, and that's the conclusions. This section provides you with an opportunity to state whether or not you met the objective of the lab and to describe what you learned in the conduct of the lab. Did you or did you not verify the physical laws you set out to investigate? If your answer to this question is yes, then you have to tell how accurate were your results. If your results were not within acceptable limitations, you need to be able to describe what went wrong. Were your errors the result of bad data, improper calculations, poor interpretation of your data, or some other reason that you should be able to explain? You need to be able to isolate and describe the most likely cause of your errors. It's not bad to make a mistake, but it's important that we learn from it. Your conclusions should also include an accurate interpretation of any graphs that you constructed to assist you in analyzing the data. any data trends that you might have observed, the effect that the limitations of the equipment may have had on the experiment. Finally, I'd like to make some overall comments concerning the actual writing of the lab, or for that matter, any paper that you're going to write. I think all of us tend to be a little intimidated by a blank sheet of paper. For some reason, most of us think that we should be able to write a final draft in one sitting. Nothing could be further from the truth. In order to write any paper, you should have a good idea about the scope of the material you intend to include. In a lab report, you already have that. You should be well aware of what you did to obtain your data. Make sure that you have a clear understanding of what you did and why you did it before you leave the laboratory. When you sit down to write the theory discussion, make sure that you understand what your basic objective was, that you understand what was the basic hypothesis you were testing. You should write everything that you can think of that has applicability to what you did in the experiment. You can always reduce it later. Once you have all the information that you think is pertinent to the experiment down on a piece of paper, then you can begin to worry about the format and the organization. The most important thing for you is to make sure that you have all the information available to you when you sit down to start. Once you have the rough draft developed, you're ready for the acid test. Read it out loud to yourself. If it makes sense when you read it out loud, it's probably properly structured. Don't read it silently. You'll insert all the missing words, and you'll do this subconsciously because you know what you want to say. If you read it out loud and stumble and run out of breath because your sentences are too long, you'll know that your instructor is going to have difficulty interpreting your paper. Again, write the report as if the person who will read it has never read about this subject before, and you're trying to convince him or her that you've just made a great scientific breakthrough. One last item. Being able to express yourself well will be extremely important to you and to those with whom you work. It's not sufficient simply to be able to analyze a problem. You must be able to relate your findings to someone else. Good writing is a much needed and appreciated talent.
Okay, now that we've seen what's expected of our students, or what we expect of our students in a written laboratory report, is there really any difference between what we expect for writing in the sciences from what one would expect in any other discipline?
I think that writing in science is pretty much the same as writing for any other discipline. Students have to inform, they have to interest, and they have to convince. The major difference is that they're dealing with a different structure, a different approach, and they have to take that into consideration, the inductive nature of science.
Right. You have to start with the question that comes from your knowledge of the subject.
Describe and explain, going back and forth between the two styles. Mm-hmm.
Reading about discoveries that have been made in the sciences, reading about the innovations and the advancements in technology is very important for scientific literacy. And this is a way in which students can increase their knowledge in science and also express themselves properly in writing.
Yeah, I find that my students often think that that our language has to be stilted. You know, we have to be very dry and very terse, and I just got asked the other day, should I say the researcher or the student, or and I said no, just write simple declarative sentences and don't get all bogged down in trying to develop some sort of a writing style that you feel uncomfortable with. I think that's where a lot of them probably get hung up when they write for the sciences. And
the shorter the better. I mean, the concise, the sentences. It's much easier to read. You know where they're going. You can't read. You can't have sentence that's going for a whole paragraph. I mean, this is ridiculous.
That's right.
Now, real short, and you just go from one point to the next, and then you just really follow the way the person is thinking when they are writing and where they want to take you.
I was reading about a funnel effect in writing for science, that you start with a broad description and you want to work that into a very narrow description. In, for example, formulating a hypothesis, your hypothesis has to be quite specific, and your observations and so on are very broad, and you have to teach them to funnel that information into the very specific statement.
Are there any special concepts that we have to concern ourselves with in the writing of the sciences that do distinguish us from writing for the humanities or the social sciences?
In the sciences, we try to express ourselves in a very concise way. The concepts have to be very clearly stated, and the sentences invariably have to be short and straightforward.
I think format has to be considered. Many times in writing in the sciences, students are going by a specific format. If it's the scientific method, they have to generate their problem, formulate a hypothesis, design the experiment, and there is a specific required format. And you know, whether they have a checklist nearby and they can refer to that checklist and say, all right, I'm at this step or whatever. But that's definitely, I think, a concept involved in writing in the sciences.
I think one more concept maybe would be that they have to be very objective. I mean, talking about the straightforward, they can say, well, I feel this, or, you know, you have to be very, the object of your sentences have to be exactly what you're talking about and not how you feel about it or how the next person feels about it. So it's very objective all the time.
And wary of bias and prejudice sneaking into the paper, that they started this project thinking one thing and they cannot let that influence them. They have to be very careful in reporting what they observe, recording what they observe, and not letting their personal prejudices affect those.
I think one more thing too, with, in terms of the funnel, you know, effect, you can't just pick a hypothesis just like that. You need to do very thorough research of the kind of work that has been done on the subject that you're thinking about. So you have to be knowledgeable in terms of what, you know, the concepts that you have to know about when you are writing a scientific paper. You can't just ask the question and say, well, I'm interested in this. You have to say why you're interested in the question.
Search the literature.
Yeah, I mean, very, very much.
Quite often, I think our students, and this is true of most of us, I know when I was a young student, I would probably take a relatively large thing to do my literature search on, and I'd go in there and find out there was more information than I knew what to do with, and I really wasn't familiar with how to narrow the topic down sufficiently so that I could have something that was manageable to write about. What are our expectations, or what kind of things do we expect to see from our students once they've written the paper and we've got it in our hands? What are the things that we're looking for?
Maybe a more operational style than a descriptive style. You know, I think we have to describe things in the way that they work, their performance, their functioning, the structural aspects of it, and not as much emphasis on the
where they look, or
right.
On the flowery
The
prose,
quality,
yeah.
maybe there's more importance in quantifying, quantification, measurement, accuracy. Although I think writing, again, for any discipline, clarity is important. Accuracy is important.
One of our faculty members, I thought, had an interesting comment here. He puts at the bottom of his handout that he gives them at the beginning of the year, he said, this is a college-level course. He says, you will be expected to use the English language accordingly. Incorrect grammar, misspelling, etc. will not be tolerated in his classes. And I think a lot of people get in the habit of writing
just
really very abbreviated, terse statements without verbs.
They drop
and
punctuation and
everything.
So I think that, you know, we as science teachers also have to kind of, I expect my students to write
correction.
Simple declarative sentences and explain what's going on and not...
Subject-verb agreement.
Yeah.
The more we ask of them in communication, I think the more we're requiring them to think critically. And again, we're getting to the goal of scientific literacy. That critical thinking is going to enhance their scientific literacy. They're on this continuum where they're working toward the mastery. And it's, you know, the lifelong learning aspect. Once they learn to communicate in writing, they'll be able to share their writing and share others' writings, and it's lifelong enjoyment.
Do we have any helpful hints that you might give to your students?
Helpful hints.
You know, how to write better in class?
Practice.
Practice, that's right. That's
I think there's no miracle, and there's no. I mean, to me, it's the practice. I mean, you know, papers that I wrote 10 years ago, to me seems awful today. I can't, you know, but you're always improving, and of course, you know, as a teacher, I'm always ready. I mean, I'm not expecting the paper to be perfect, the first paper or the second paper, but it's always an improving. You know, mechanism. I mean, we improve on the one before.
Most students think that good paragraphs just happen spontaneously. They don't realize that they have to work over and over and over writing good paragraphs. And they think that just writing a term paper requires just writing it just one time and then submitting it for
Sit down
grading.
and let your pen do the walking, right?
Exactly.
Yeah, well, my wife used to badger me. I was not a very good writer when I was young. I don't claim to be a good writer now, but I used to sit there with the pen poised over the paper in hopes that something would come to me. And my wife used to tell me all the time, well, Mike, just write something. And you're right. You know, I wanted to be able to write the written report down one time. When I another quick anecdote that my thesis advisor in college, when I handed him my first thesis, he graded all these things, and he'd given it back to me, and it was read everywhere, absolutely read everywhere. And then he says, Mike, he says, I don't understand it. He says, you speak like a poet and you write like an idiot. It was somewhat embarrassing, but he was, you know, I was using a lot of jargon and not trying to write really properly, so I had to go back and reinvent everything that I'd done practically with him.
I think they have to go back to a very elementary level and bone up on what is a good paragraph, what makes a good paper, what are the structural components required here. Have a checklist and check it off, and is it correct, and ask someone else to read it. A big part of doing science is, can someone repeat the science I've done? And if I've gone through the scientific method, observed and experimented and so on and so forth, can someone else read my writing and then
That's very
repeat this?
You gotta go back and duplicate the
That's required. I
experiment.
mean, you have, when you write a scientific paper, and if it's going to be published, it has to be written in a way that anybody can pick up that paper, read your methods and your materials, everything that they need for that experiment, and be able to duplicate that. But I think another thing for the hints, I was thinking, not only do you have to write out your thoughts, but I think before that, though, you want to have a little bit more structure in terms of you need an outline. Like within your introduction, you know what you want to write, and then you can write your thoughts within the introduction and then organize it later. But if you try to write without a structured outline to begin with, it's going to be too difficult to put things back together where they belong. I mean, it's hard enough. Sometimes you do mix results and methods and conclusions with the discussions, because you think, you know, you discuss something, so you're going to conclude about it. No. You got to wait till you get to the conclusions. So it's important to have some type of an outline. Then you can write your thoughts. Then you organize them. You leave them alone for 2 days, and then you go back. That's how you go first draft, second draft.
One of the troubles that we run into, probably with most of us, me included, is that I tend to leave writing to the last minute, you know, and especially when you're fearful of writing. You know, if you're comfortable sitting down writing, you know, it's no problem to sit down and start writing, and then, as you say, leave it aside for a couple of days and then come back to it. But for those of us who have to work at writing, and most everyone has to work at it. But some of us think that everybody else does it easily. So one of the things that I think I found most helpful, and I didn't learn this until very late in life either, I used to have a boss that any written piece of correspondence that we would take to him, he would sit there and read it out loud to you in your presence. And usually after about 1 or 2 sentences, you were reaching for the paper trying to get it out of his hands because it was an embarrassment.
You know, oftentimes we can get away with incorrect grammar and verbal communication, but it is very difficult to do that in writing. It's in black and white right there, and everybody can read what has been written.
That is so true.
A lot of really probably very intelligent people who understand concepts very well, but who are unable to explain them, or either verbally or in written communication, really don't get the job done. You know, we have to not only have good ideas, but we have to be able to put those things on paper and communicate them to others, and communicate our discoveries and those sorts of things. And if we can't do that, it really doesn't make a whole lot of difference that you've done the research, because the only one that you've made smarter by doing the research is yourself.
So you see, you do write a scientific paper each time you write a lab report or any research paper for a science class. Write with the idea that your paper will be published. Express yourself clearly. Treat your audience as if this were brand new information, and you'll have no trouble writing for the sciences.